So if you want to review for the quiz, again, I would copy the problem down that I'm doing, pause the video, try the problem, and then watch the video. And if you can get through these sample problems and understand them really well, you should do just fine on the quiz tomorrow. Okay, first question is going to be 64 to the negative 2/3, and evaluate without a calculator. Okay, so the first thing I'm going to do is recognize I could write this as a root. And if I think about what the cube root of 64 is, well, that's 4 times 4 times 4. So that's 4 raised to the negative 2. And the negative just means to flip it, which now becomes 1/16. Okay. Next one, let's do negative 16 to the 3/4. No, I want to make it, sorry, that's not going to work. What is cube? Let's go negative 8 to the 2/3. Okay, the point of this problem, and where you might miss it, is remember, if I want the whole thing to be raised, and now my marker's not going to work. If I wanted the whole thing to be raised, negative 8 raised to the 2/3, I would put it in parentheses. But this one is not in parentheses. This one, the 8 is being raised to the 2/3, and then it's being multiplied by negative 1. So think of the exponent as just being applied to the 8, not the negative sign. If I wanted it applied to the negative sign, I would have put the negative 8 in parentheses. Same is true in the calculator. If you want to raise the number 8 to the 2/3 and then make it negative, you would just type negative 8 raised to the 2/3. If you wanted the whole thing, negative 8 raised to the 2/3, then you would put it in the calculator with parentheses. So what I'm going to do is recognize that this is negative cube root, my board is giving me fit still, cube root of 8 squared. And the cube root of 8 is 2. 2 squared is 4, so my answer is negative 4. If I had put this in parentheses, then it would be the cube root of negative 8 squared, and the cube root of negative 8 is negative 2. Negative 2 squared would be positive 4. Okay, but I didn't put it in parentheses to start. So my answer is actually negative 4. Okay, so be careful on that one. All right, the next one I want to have you simplify to write it in its simplest form. So let's do this. 1 over 3 to the negative 2/7. So the first thing I'm going to do is go ahead and flip it. So this becomes 3 to the 2/7. Now I know this is the 7th root of 3 squared, which is the 7th root of 9. Okay. Next one, let's do, I'm trying to change the numbers up a bit as I'm looking at the quiz and writing these questions. 27 over 5. The cube root of 27 over 5. Well, I could rewrite this as the cube root of 27 over, over the cube root of 5. The cube root of 27 is just 3, but now I've got a root in the denominator, and this is a cube root. Okay, so be careful here. You can't just multiply it by the cube root of 5 like we could with the squares. And the reason is, if I write it as a fraction, this is 5 to the 1/3. If I just multiply that by 5 to the 1/3, in the denominator I have 5 to the 2/3, which is still a root because I have a 3. So I need to get it to 5 to the 3/3. That's my goal. I want this to be, after I multiply it, 5 to the 3/3, because 5 to the 3/3 is just 5 to the 1, which is just 5, and now I've eliminated the root. So what can I multiply 5 to the 1/3 by to get 5 to the 3/3? 5 to the 2/3. Okay? So now I can rewrite this as 3 times 5 to the 2/3 is the cube root of 25, all over 5. And I'm done. I can't simplify 3/5 any further, and I can't cancel anything out here because this is under a root and this is not. Okay? All right. Next one, write the expression in simplest form. Okay, so when I multiply two bases that have exponents, I add the exponents. So this is just a fraction problem. And using John Baylor, because neither one of these, the least common multiple of both of these is the product of the two, I can multiply these together. 3 times 3 is 9, 4 times 2 is 8, this is 17/12. So my answer is x to the 17/12. All right. Next one, I'll use the same. Actually, I'll just use this. 2/3 raised to the 1/2. Okay, this time I'm raising an exponent to a power, so I multiply these. I don't add them. Okay, so this becomes x to the 1/3. Okay, now let's do cube root of 64, x to the 7th, y to the 5th. So just to break it up, some of you may be able to do this a lot quicker, but just in case some of you are struggling, this is how I would do it, just very systematically, taking it in chunks. I would take the cube root of 64 times the cube root of x to the 7th times the cube root of y to the 5th. The cube root of 64 is just 4. Now, there are a couple of ways to do this. One way is to rewrite x to the 7th and break it apart in cubes. Okay, because this is x cubed, then I would add x cubed to get x to the 6th, and then I have one more as x to the 7th. I could do the same thing this way, and then I can recognize the cube root of x cubed is just x, x. I can't do this one anymore, so this stays in. This is y, and I can't do this one anymore. That stays in. And I have all of this times 4. So that gives me 4x squared y times the cube root, and I can then bring these two together. This should be a y, sorry about that. Y squared of xy squared. Okay. Another way of looking at how to simplify the cube root of x to the 7th is think of it as a fraction, and then just ask yourself, 3 goes into 7 how many times evenly? 2, so there's your x squared, and I have 1 left. There's your cube root of x. Okay, same with the cube root of y to the 5th. I could rewrite it as 5/3. 3 goes into 5 evenly 1 time, which is just y to the 1, and then I have 2 left, y squared. So there's my y to the 1 and my y squared. A couple of ways you can do it. Okay, a lot of times where I'm at the point now where I can recognize this, I just look at 3 goes into 7 2 times evenly. There's x squared, 1 remainder, x stays in, and then move on to the y, and just do it without breaking it apart. But until you get to that point, I would highly encourage you to just break it apart in chunks and evaluate each one until it just starts coming easier and easier for you. Okay. Next problem. x to the 3/4 times y squared divided by x to the negative third times y to the 2/3. Okay, what I would probably do with this one is just recognize I have the same base here and the same base here, so I'm going to just focus on the x's first. When I divide two exponents, I always subtract. So this is 3/4 minus negative 3, or 3/4 plus 3. And then to handle this as a fraction, this is 3. If I multiply these together, I get 4. 1 times 3 is 3. 3 times 4 is 12. So this is 15/4. Okay, so I know it's going to be x to the 15/4. We always write it as an improper, never as a mixed number. And then I handle the y. So it's going to be 2 minus 2/3, which is 2 over 1 minus 2 over 3. Again, multiply, and I'm subtracting this time. Okay, y to the 4/3. And I'm done. I can't simplify that anymore. Okay, the next two problems now are dealing with graphing. Actually, I've got 3 more problems. Dealing with graphing, square root and cube root functions. So the first one is, it just says describe how to obtain the graph. Let's see if I can get my board to work. Y equals the square root of x plus plus 2, come on, marker, minus 1 from the graph of y equals the square root of x. This just says describe. You don't have to graph it. I just want in words, how do I go from this graph to this graph? So what I would do is I would take this graph, I would shift left 2 units and shift down 2 units. Remember the general form. Okay, so if h is positive, there's a negative sign there. So if I shift right, I'm going to have x minus something. If I shift left, it's going to be x plus something. And then the k is always whatever sign it is. Shift down if it's negative, shift up if it's positive. Okay, for that problem, all you need to do is describe. The next problem on the quiz will be a multiple choice, and you will have to choose the graph for a problem similar to this. Okay, so instead of giving you multiple choice here, I'm just going to graph it for practice. Okay, so I'm going to start with just the graph of y equals a cube root of x. So I know it goes through 0, 0. I know 1, 1, and negative 1 is on there. I'm doing y equals the cube root of x. So when x is 8, 1, 2, 3, 4, 8, y is 2. And when x is negative 8, 1, 2, 3, 4, 5, 6, 7, 8, y is negative 2. So I can just kind of sketch this. It's going to keep going, just gradually getting bigger and bigger as it goes. Okay, so now to graph this one, I'm going to take the original graph, shift it left 3, up 2. So each one of these points, I'm going to shift left 3, up 2. Left 3, up 2. Left 3, up 2. Up 3, sorry, because it goes, well, it's up 2 from here. Left 2, no, 3, get it right. Left 3, 1, 2, 3, up 2. And then this one is left 3, up 2. And now you can kind of see it's parallels the same graph. It's just shifted the whole thing left 3 and up 2. So if you can just do a quick sketch, even like on your paper, or even in your mind, picture what the cube root of x looks like, that blue graph there, and then take that graph, shift it whatever direction the problem you have on the quiz is, left and down, or left and up, right and down, right and up, one of those two. Okay, next question. There are 3 parts, each one a separate question, but they're all related to the same graph. So I'm going to go ahead and give you one similar. Use blue. 3 minus the square root of x minus 2. Okay, again, not the same problem on the quiz, but similar. We haven't really seen one in this form. This isn't 3 times the square root of x minus 2. This is 3 minus the square of x minus 2. So what I would do if I were you with this problem is I would rewrite it, and I would just switch these two. Okay? So it's going to be negative square root of x minus 2 plus 3. Okay? Commutative property of addition and subtraction says you can switch those two and they mean the same thing. Now it looks similar to the general form. Right? This one really didn't. So what I did is I just put it into the same form so that I could match it up to this. And then I can ask myself, what does each part of this equation do to the graph? The negative is going to flip it, right? This means it's going to shift right 2. This means it's going to shift up 3. Okay? So the first question says, what is the domain? The second question says, what is the range? And the third question says to graph it. I recommend you jump to that third question, which is the last question on the quiz, and go ahead and graph it first, because then you will be able to see the range and the domain very easily. Okay, so I'm just going to take this. I'm going to go ahead and graph the square root of x first. 0, 0, 1, 1, 4, 2. And all I'm doing is picking some points and graphing the square root of x. Remember, it's never going to go past 0, 0 because x can never be negative. And then I'll just do one more. 9, 3. 1, 2, 3. 1, 2, 3. There it is. Okay. So there is y equals the square root of x. Now I'm going to use this to go ahead and graph y equals negative square root of x minus 2 plus 3. So first off, I'm going to flip it. That's what the negative does. So I've taken care of this. Now I'm going to shift each of these flipped points. I'm going to shift this one right 2 and down up 3. Sorry. 1, 2, 1, 2, 3. This one's also going to go 1, 2, 1, 2, 3. I'm going to get rid of that point so I'm not confusing myself. This point is going to go 1, 2, 1, 2, 3. And then this point, 1, 2, 1, 2, 3. And get rid of those. So now I have it flipped upside down and shifted right 2 and up 3. Okay, so this red one represents the graph y equals negative square root of x minus 2 plus 3. Now I can see the domain pretty easily. The domain starts at 2 and it goes to infinity. The range starts at 3 and goes to negative infinity. Do you see how it's never going to be bigger than 3 on my graph? It's going to get smaller and smaller, going down to negative infinity. So that's really important on your range, that you recognize it's negative infinity. Okay, so those last 3 questions on the quiz will all have to do with the same equation. Again, I recommend you jump to the very last problem and graph it first, then use your graph to answer the domain and range questions before that. Okay, hopefully this helps. Again, stop, do the problem, start it again, see if you're getting it right and understanding the concepts. If you can get through this video doing all the problems correctly, the problems on the quiz are identical, just different numbers. I can get this to stop there.